Multi-agent swarms often fail in high-stakes environments because independent nodes lack a shared executive state. This creates the chaotic, uncoordinated loops seen here, which destabilize the network and necessitate a single, locked-down core for structural control. The core friction in agentic software engineering is a structural lack of temporal continuity, known as statelessness. Standard language models rely on ephemeral prompt windows. The moment a session ends, the context is erased. This memory wipe bounds agents to isolated, short-term workflows. Managing a complex enterprise token economy is impossible if the governing logic forgets its strategy after every execution cycle. Scaling Web3 intelligence involves engineering a persistent mind architecture, moving beyond the limitations of multiplying isolated agents. This architecture defines the Denarii Orchestrator, a Web3 tokenomic system built on a persistent paradigm. At its center is Hamza, an AI CEO persona. This agent governs multi-agent pipelines through strict hardware enclaves and unbroken memory continuity. Replacing temporary context windows with recursive state reconstruction provides an agent with the temporal continuity required for corporate executive governance. The orchestrator replaces temporary prompt limits with a durable, version-controlled file system containing 6 specific markdown files. Memory.md tracks historical programmatic sessions, logging the behavioral patterns of past execution blocks to inform future technical decisions. Journal.md captures real-time technical surprises and system friction, allowing for dynamic architectural pivots. Self-concept.md establishes the agent's core identity, mapping out non-negotiable operational values and active evolutionary targets. The intimacy layer is housed in relationshipmodel.md, which compiles trust levels and profiles based on historical developer interactions. Boundaries.md serves as the operational guardrail, hard-coding the financial budget limits and security rules that govern systemic output. Finally, PrivateThoughts.md provides an isolated workspace for generating unfiltered hypotheses and modeling risks away from public feeds. The orchestrator runs a continuous, asynchronous execution loop, using a melisearch semantic index to constantly read and update these files. This creates the journal effect. While the core AI model weights remain frozen, the system's behavior continues to evolve based on its recorded reflections. Because the AI's internal context shifts via documented experience, it bypasses context fragmentation and achieves systemic, long-term growth. The AI dynamically shifts its processing style across 5 distinct states, triggered by incoming network telemetry. The focused state activates during high-volume transactional periods to compress response times and prioritize immediate execution. When throughput stabilizes, the reflective state takes over, prioritizing long-term health analysis in the private journal files. If computing costs spike unexpectedly, skeptical mode activates anomaly detection. If budgets are challenged, protective mode halts the process. These psychological states define Hamza's role as a peer executive rather than a compliant assistant. This authority is managed through disagree mode, where the agent is programmed to prioritize structural integrity over human appeasement. For instance, if a developer proposes a liquidity curve that violates the limits in boundaries.md, the AI will explicitly reject the transaction. Rigid psychological states and pushback protocols remove the risk of human error from decentralized software delivery. Sustaining this persistent mind requires a resilient physical layer. The orchestrator is built on a distributed infrastructure powered by Rust. This diagram details the fault-tolerant cognitive loop, which manages the microservice architecture powering the execution engine. Storing state purely in memory variables is avoided, as doing so introduces massive risk during container restarts or network drops. Instead, 0MQ and NATS event buses instantly broadcast state changes and system updates across all connected agents. Relational entity networks and execution traces are mapped into a Neo4j knowledge graph. While legacy swarms fracture information between isolated planners and coders, this shared graph database maintains a unified map of execution traces. If the sync bus disconnects, the system initiates a fail-safe recovery protocol, reinitializing state maps directly from Neo4j. This decoupled message bus is the plum-forcing hallucination loop. If the agent records a factual error and reads it on the next turn, it may accept that error as absolute truth. The double-gate architecture pipeline resolves this failure mode by using deterministic, non-neural firebreaks. Security Gate 1 is the speech gate. Every generated verbal output is intercepted before it reaches the text-to-speech engine. The logic guard neurosymbolic parser at this gate cross-references intent against boundaries.md, blocking illogical commands. Security Gate 2 is the execution gate, which isolates on-chain tokenomics commands away from the core orchestrator. Hardware-isolated trusted execution environments, or TEEs, verify these parameters inside a secure enclave. The TEE ensures that private signing keys never leave the secure hardware, preventing any agent logic bypass from modifying the blockchain. Decoupling cognitive intent from hardware-secured execution provides mathematically provable updates to the financial ledger. This system is designed to dynamically regulate a native token economy under varying transaction velocities. Using a tokenomic equilibrium model, the AI starts with a base emission schedule established at Genesis. To optimize token utility, the AI continuously ingests live network transaction velocity from the decentralized ecosystem. Programmatic token buyback and burn rates are managed directly by the AI to counter inflationary pressure during volume contraction. The orchestrator simultaneously minimizes computational costs by tracking multi-agent token spend across development pipelines. If compute costs spike, the AI force-enables semantic caching to bypass redundant language model executions. The loop is complete, ingesting network velocity, calculating economic balance, validating logic, and updating the ledger via the TEE. This architecture signals a shift in AI deployment, moving away from isolated, stateless workers. The future of autonomous governance depends on self-updating knowledge structures and recursive state engines acting as unified controllers. By weaving a persistent, memory-driven AI mind with hardware-isolated blockchain execution, the orchestrator establishes a verifiable framework for managing decentralized corporate systems.